Good morning, calculus students. Here we go. Today we're going to do lesson 29. Like I said, calculus is getting easy. You're going to find this lesson to be really easy. The entire lesson is on this first page right here. So if you could please read the first paragraph of lesson 29. It talks about Newton and Leibniz. It gives you when they lived. It talks about them developing calculus independently. I think it's more of a miracle. They both discovered calculus independently. Newton used notation for the derivative as y dot. That eventually transformed into y prime, which is what we use now. Way back when I was in college, some professors were still using y dot. Leibniz, he came up with the dy dx, because remember the derivative is the change of y over the change of x, the slope of the tangent line, which is rise over run, change of y over change of x. So we're going to use Leibniz's notation then to come up with the differential. If we look at dy over dx, that gives us the derivative. If I cross multiply the dx, I see that dy equals the derivative times dx. This is finding the differential. So if I want the differential, that means I simply want dy, then I cross multiply the dx over there. Finding the differential, as being asked here, is going to be adding that operator at the end of my equation. So look at the first example. Let y equal 3x to negative 2 plus 2x squared plus 1. Find dy. If it had said to find dy dx, then I would have just found the derivative. Let's find dy dx. Negative 6x to negative 3. Remember, we multiply by the coefficient, subtract 1. Plus 4x, the derivative of the constant is 0. That is dy dx. But I want the differential. So this dx gets multiplied over here. Dx, and that is the differential. You don't have to show that step. You can just say dy is negative 6x negative 3 plus 4x dx. That is when we find dy. That's finding the differential. So you have to read these questions carefully. So looking at the second one, let y equal sine of t plus cosine of t. Find dy. I'm finding the differential. So dy is cosine of t minus sine of t. I'm going to write my operator in terms of t. I have now found the differential. That's it for lesson 29. Not bad. Okay, tomorrow you're not going to do lesson 30 tomorrow on Tuesday. Instead, I am going to email each of you your test and your quiz. So the test from this past Thursday, the quiz from the Thursday before. I would like you to work through your quiz and your test, identify any questions. Hopefully you're working together. Hopefully you have access to call somebody, maybe get on the line with somebody, work math together. And any questions that you cannot figure out, please text me. Text me whether quiz through lesson 24, test through lesson 22, or any homework assignments. Text me your name, the question number, and then give me a little bit and I will text you the solution back. If you do not understand the solution, I am so happy to FaceTime you and walk through the solution with you together. This will only be for a week. I think we're going to still proceed as normally. We're going to carry on. So please check your emails. Please check RenWeb every day before 8:15. All right, I'm praying for each one of you and I look forward to seeing you. Bye.